This video shows how to use the high-low and regression methods in Excel to determine the fixed and variable portions of a semi-variable cost. Remember, variable costs increase as production increases, and fixed costs do not change with production. This isn't GAAP, but knowing the contribution margin is useful for managers to understand how their cost behaves. As in the formal income statement, we start with sales. An income statement with the contribution margin approach is to have sales less variable costs to arrive at the contribution margin. From there, you subtract fixed costs to determine operating income. We broke out variable costs and fixed costs, but what about mixed costs or semi-variable costs? First, we have to get back to fixed and variable costs. The fixed costs don't change with production. Think about building depreciation. That expense occurs over time and doesn't increase because production increases. Fixed costs are independent of production. On the other hand, variable costs are dependent of production. When there isn't any production, the variable cost is zero. But there is a rate per unit produced, so the more units, the higher the cost. The variable cost is dependent on production. A mixed cost or semi-variable cost has both. There is a fixed portion independent of production and a variable portion that depends on production. We have to figure out each part. For a semi-variable cost, the total cost is equal to the fixed cost plus the variable portion, which is the variable cost per unit times the units produced. This is easy to do in Excel. Imagine the cost to run a machine is a combination of a fixed rate plus a variable rate per unit made by the machine. And in this example, we've got kilowatt hours in column B. That's the independent value in our problem. And in column C, we have the cost for the machine. That amount depends on the number of kilowatt hours used by the machine. Here are the steps to break the fixed and variable costs using the high-low method. The high-low method is a simple way to segregate costs with minimal information. It only takes the high and low cost, and it assumes all the costs are behaving alike. It also assumes that the high and low costs are not unusual, or what we call outliers. The simplicity of this approach assumes the variable and fixed costs are constant, which doesn't really replicate reality, but it's easy to do in an off-the-cuff meeting when you're talking about hypotheticals. We'll talk in a moment about another cost estimating method called least squares regression. That provides better results, although this method requires more complex calculations. So for the high-low, we want to know the low and high costs. So it's easy to first sort them, and here are the instructions. Select all the cells with the data. On the Excel ribbon, click Data. In the Sort and Filter group, click on Sort. In the Sort by drop-down, select the column. We are using the kilowatt hours because that is the independent value. The cost for the machine changes with the kilowatt hours and it depends on it. For sub-searches, if you need them, you'd click Add a Level. Select the order. I'm selecting the smallest to the largest. And finally, click OK. That sorted our data so we can easily see what is the high number of kilowatt hours and the low number of kilowatt hours, along with the related costs. We've already said the cost depends on the kilowatt hours used. By taking the high amount of hours and the low amount of hours, we know the change in hours. If we do the same for the related costs, we know the change in costs. So simply, if we divide the change in cost by the change in hours, we can find the variable rate. So here is the change. The kilowatt hours changed 3,400 hours, and the cost changed $408. Dividing them has a variable rate of 12 cents per hour. If we go back to our formula, we can find the fixed amount. In June, we had 5,500 kilowatt hours. At 12 cents per hour, we have a variable portion of $660. We know the difference between the total $860 cost and the $660 variable portion, and the fixed cost has to be that $200 difference. We prove it by calculating it with the high volume of kilowatt hours. Since we've taken only the high and the low data points, we can prove it only with these 2 points. The other months may not be on this direct line, and they may not show the same exact formula. That's a problem with this quick and easy high-low method. But since this is for approximation purposes, we have a total monthly cost for machines formula of $200 plus 12 cents per hour times the number of hours. We can use this to estimate what our costs are going to be for machines in the future. When there isn't an immediate need for an approximation of the fixed and variable portion, a regression is a better method. Least squares regression is a statistical technique that may be used to estimate a linear total cost function for a mixed cost based on past cost data. Least squares regression mathematically calculates a line of best fit to a set of data pairs, the series of activity levels and the corresponding total cost at each of those activity levels. The calculation involves minimizing the sum of squares of the vertical distances between the data points and the cost function. The name least squares regression also reflects this proposition that the ideal fitting of the regression line is achieved by minimizing the sum of those squares for the distance between the straight line and the data points. Here is how you do this in Excel. First, click on the Data tab. Open the Regression Analysis tool. Define the x-independent and y-dependent range. Remember, the y range is the dependent variable, and the x, or kilowatt hours, is the independent variable. Now, I have the output going to a new worksheet, so it doesn't get in my way. Here is the summary of the regression. In the bottom right, you can see the intercept is 200. This is where the best fit line meets the y-axis. In cost terms, it's the amount of cost when production is 0. In other words, it's the fixed cost. You can also see the 12 cents per unit is the first variable, and in our case, the only variable. That is the variable portion. So we have the same results as in the high-low method and the same formula, although in real life that is very uncommon. Another thing to do is graph the regression. In Excel, if we graph the data, we can draw the best line, which is the least squares line. Here are the instructions. I find a blank area and I insert and I select my chart type. Then I right-click on the chart and select the data. Remember, the y-axis is the variable. Then I select the plus sign that's next to the chart. I select the trend line and linear trends. If I wanted to add the R2 value, I would go into more trend line options and I would display that amount. The chart ends up looking like this. I drew a line to continue the least squares line that was already there, and you can see it intercepts at the Y, where the cost is $200. That's the fixed cost because there's a cost with 0 production. The slope is at 12 cents per hour, which is equal to the variable cost. In summary, the high-low method is simple and for quick purposes. Least squares regression is more precise and better for final decisions. I hope this helps. If you've got any questions, please let me know.